Great. Okay. Thanks, Anastasia, for that. I guess we can get started. So this Zoom meetup is basically the third in a three-series demo series that we gave at the Nexus conference in September. The first meetup basically showed you 5 containers running on a server where we were running LISP and Nexus together as 10 nodes using an 11th container that was the mapping system. And what we showed is we were able to n-square communicate among them, as well as do some multicast among them, where everybody joined this group right here, and the XTRs 2, 4, and 6 joined that one, and 3, 5, and 7 joined that one. So we showed the kind of the capabilities of an overlay, a LISP overlay, where Nexus was sending packets and we were also doing pings. So that was using a centralized mapping system. And then when we did the second meetup, we said, let's go ahead and create another 10 containers. We call them decent containers, as in LISP decentralization, by showing how they can run by themselves without a third-party mapping system. So we only ran the 10 containers, and they were the mapping system for themselves, okay? And then we did the multicast and ping stuff among them. Now, what we want to do today is we want to show you that we're going to run these XTRs as crypto XTRs, and what that means is that they're going to be dynamically allocating their key pairs. In other words, a private and public key, as well as an IPv6 crypto EID. We'll explain those semantics in a minute. And then they're all going to register to this MRMS container that's being used as the mapping system. Now, since they all have crypto EIDs, they can all sign their control plane messages. So all the LISP control plane messages are signed by these XTRs and then verified by the map server. So what we're trying to show in this demonstration is that IPv6 and IPv4 could run over an IPv4 underlay through NAT boxes, and that we're doing crypto in both the control plane and doing encryption in the data plane, okay? Any questions before I continue? Okay, so let's have a look and see. We showed this a couple meetups ago, but let's look and see what these XTRs look like. Well, they're connected. They're using Docker containers, so the Docker bridge is acting as the underlay, and that's how they can all access each other kind of physically. So we have these containers. We have 10 of, even though I show back here 25, we really have 10 running because we're doing multiple projects on this server. But the way these containers are set up is they look like a regular IP node that's running the Nexus application and the Lispers.net network layer, and that they are multi-homed. In other words, they look like they have 2 Ethernet ports, one attached to a Docker assigned address and another one that's statically configured. If we went over to the web interface right here, let me make this a little bit better. And we looked at, where did it go? Right here. There we go, this one. Oh, there, we put in one window there, that's better. Okay, so if we look, this is crypto XTR1, and what it's saying is these are the EIDs that they're using. So they're using an IPv4 EID that we use the 240 space for, and it dynamically allocated these 120 bits for the IPv6 address. So these crypto IDs are always prefaced or prefixed with FD, okay? But note that they're actually, so what I decided to do was, let's make the IPv6 look like it's single-homed just on Ethernet 0, and let's show IPv4 is multi-homed on both of the interfaces, okay? So we're gonna keep this map cache here because we're gonna show you packets moving back and forth. Okay, so let me go to the actual, okay, this is the server. And as you can see, we have 10 running right here, 10 containers, 10 Nexus nodes. This, you could ignore this. This is another project we're working on. And of course, a mapping system as well. So let's go over to the map server right here, and we can show you, let's refresh the screen. And what we can show you is that these crypto containers are being, these are the EIDs that are being registered. So here's one, and it's IPv4 equivalent. So you see 2 per each one. If you click in, you'll show that the EID that's being registered is currently being registered and being authenticated because this signature is being verified by the map server, and that's why it's registered. And as we said, it was single home, so that's the IPv4 RLOC address of the underlay. And of course, it attaches a name with it, so it's easier to manage and stuff. If we just go back and look at the IPv4 equivalent, we see the same signature that's for the register of this IPv4 EID with the 2 RLOCs. And notice the RLOC names are saying this is crypto XTR3 on Ethernet 1 and crypto XTR3 on Ethernet 0, okay? So now let's come here and let's attach to one of them. And what it's been doing is we have this thing called, I have this ping mesh thing running. Let's see if I still have it. Yeah, there it is. So what this is going to do is, since every time we bring up the containers, the IPv6 crypto EIDs are reallocated. So a new key pair is generated, the public keys are put in the mapping system, and the crypto EID is then used. So what we have to do is that this script actually has to go ask the mapping system. It actually has to go ask the mapping system, what are the crypto EIDs? So it finds out all the ones that are being registered, and then what this script does is then goes and pings each one individually. And you can see we're sending 5 pings to each of these different crypto EIDs. So kind of, if we did this in XTR1 through XTR10, there would be an n squared mesh of packets going back and forth. Let's look at crypto XTR1's map cache, and let's see who he's talking to. You can see that these light green means that a packet has been sent, at least one packet has been sent in the last minute, and dark green means that it's been sent within a second. So we've had some packets being sent here. Now what's going on is these packets that are being sent across these IPv4 EIDs these are packets generated by the Nexus application. And then the packets down here are being generated by the ping mesh. And you can see how these packet counts have lit up for all the different EIDs. Now what's important is when this system, say, is encapsulating packets to this EID, the outer header has this IPv4 address. And what it's doing is, since you see this encap crypto cha-cha, we're using the cha-cha cipher to actually encrypt the packets. And on this side, the packets are actually being decrypted and then decapsulated to deliver to the application. Okay. Another word about the mapping system is for these EIDs here, this entire set, to be verified, their public keys must be accessible. So what we do is we have these public keys that are registered as EIDs in the form of this hash and the lower 120 bits of the crypto EID. That allows the map server, when it sees a registration for, say, this guy here, C8FD, it looks up CFAD in its own mapping system to find the public key so it can verify the signature. Okay. So that's the demo. If there's any questions, now Colin's on the call, and that's great because he could then describe how he wants to use these crypto EIDs that are being used at the LISP level, how they can be used at the application level to avoid spoofing and other things. So Colin, I'll give you the floor if you want to comment on that.
Of course. Can you hear me, everybody? Let's see. All right.
Yeah, I can hear you. Go ahead.
You can hear me?
Yep, I can hear you.
Great, great. So one of the big things that we've noticed, so we haven't really had an opportunity in the past to really solve some of these issues that we have with IP spoofing. The main thing is that you can't really tie an IP address to an identity, since you can always change them with VPNs, which does have a positive quality where you get higher layers of security. And you also can prevent yourself from being tracked by people you don't want to. But the big thing that we've been able to really do, and that's where LISP comes in, and it makes a really great use case for Nexus and vice versa, is that the ledger can be tied to the specific EID, so that your signature chain or your account per se on the cryptocurrency or the blockchain itself is tied to a routing identity. Now, we get a really, really unique use on this to prevent fraud. If a lot of you know that you log into an account with a different IP address, it says, oh, well, you're logging in from a different device, so on and so forth. And so certain services have to provide certain levels of, I guess, security, but also at the same time, I guess, leniency. If you log into an IP address that's right down the street, you know, you don't want to always have to be clicking and verifying and things. So that leniency creates security precautions or problems where somebody can log in from an IP address near you, maybe using, let's say, reverse proxies and botnets or things like that in order to target your accounts. This way, you actually have a static endpoint identifier that's tied with your cryptographic identity, so that with the Nexus APIs, you'll be able to log in somewhat with your SIG chain, and that'll tie in with conventional authorization systems that then tie in with your crypto EID. And so with your crypto ID being located to your signature chain, you know exactly who you're talking to. And the other beautiful part is that you can open the direct peer-to-peer messages between participants from EID to EID, no matter what network you roam on. So you're always going to get a higher grade of security. And you're going to reduce any of the ability for things to happen. Since this is an overlay, we also make the overlay kind of a privilege. And this is something Dino and I have thrown around more often than not. That you basically, we're going to have kind of the insecure underlay where you first go, that's the untrusted web. And then as you get access to the overlay, you're actually getting access to a more trusted web, kind of like the opposite of the dark web, where we have the dark web where all these insidious things can happen. You don't know who's who. People are all spoofing their IPs. They're all on Tor. This way, it's kind of a step up in the positive direction where you know who you're talking to. You don't exactly need to know where they are, because the RLOGs can be changed and spoofed and whatever, but you're going to know that that's a specific person. They can't spoof it because it actually have to crack the cryptography. And then you know that there's an account. Let's say you want to send a transaction to somebody. You can actually verify with them first. Say, hey, I just want to make sure you're online. I'm about to send you a payment. And using the peer-to-peer chats that way is another really important part, so that different web services can use this kind of elevated, trusted net, I guess, on the internet, combining LISP and the Nexus signature chains together, which I think is going to really prove to solve a lot of problems. I mean, look at these things that we have with, you know, the identity crisis. You don't necessarily have to prove somebody is somebody, but you have to have a service know that that somebody is the somebody that registered for that service. And then when you have that consistency and persistence across, you're going to know when that same person is coming back, and it's not a compromised account or somebody trying to pretend to be somebody else. And that's where we have big problems we see with SIM swapping, people pretending to be somebody else, web services where your account can be compromised. And there's a lot of people saying, hey, your account's being logged in from a different IP address. Well, you wouldn't be able to forward your EID, since your EID would be something that would require to be logged in from Nexus first. So that's one of the really, really positive qualities that we're seeing. And we're kind of naming it like a trusted net. And that's, Dino can explain too a little bit how the internet itself really wasn't designed to be secure. It was just designed to work. And now I think we have a lot of options to be making it more secure and making it something that we don't need trusted third parties, but we can just be trusted in cryptography itself.
Yeah, I mean, when the internet was originally built, we wanted everybody to talk to everybody, completely open. Of course, it was a set of people from universities and research organizations that all worked on a project similar to this one, and everybody trusted each other. But as the internet grew, it turned out to be a bug and not a feature that anybody could send a packet to anybody, because that means if you had resources, you could DOS attack links, tail links, and even DOS attack routers in the core of the network to bring large portions of the network down. So it's kind of going full circle where should we, I mean, it's really a question is, should we have admission control, or should anybody be able to talk to anybody? Now, maybe down at the packet level, we want to send packets anywhere, but maybe the users that are connected to the periphery of the network need to have some kind of admission control. Not anybody could really join this conference here unless they've had the URL to join in. It's kind of a form of admission control in some ring of trust, which is the Slack channels or whatever. It's relatively open, but it's not as open as doing broadcasts to like Facebook or social media and stuff like that. So I think we're kind of, the internet now is kind of learning from the crypto world that you have to build trust and prove trust over time before you can use any sort of resources. And by doing that, I think we'll be able to build some sort of shareable economy where if there's free cycles on Colin's machine, maybe he's not at his apartment or whatever because he's traveling, well, maybe he could rent out his bandwidth, his CPU cycles, his network, all that sort of stuff. But it's being done, he's doing that to trusted parties. Right?
Yeah, and it's also, I mean, I believe in openness, and I believe openness is a good thing. But I mean, if we look at it in kind of a rough analogy, if you're completely open in the middle of a battlefield, you're going to get shot. And so I think openness should just be open to discernment for everybody, where the internet can be an open place, but a place where people can openly select what type of interactions they want to be receiving on it. I know sometimes, I mean, even a link, having it as a closed thing, well, how do we know that anybody that just doesn't have that link isn't going to come in and just, start doing things that are going to be negative to the conversation? So I think with the internet, it's going to become something more like where you're going to be able to create trusted groups or places that that you want to authorize people that you want to talk to. Sometimes you want to block a friend or, that you've had a fight with, or sometimes you don't want to have anybody being able to attack your computer because they're going to be able to DOS. And the overlay having kind of an access control coming from the blockchain is going to be a really important part, because you're going to be able to set those preferences. And this is something we've talked about too, as well. Hey, I only want to be contacted from 9 to 5 my times, and nobody else can send any message. We can do that with the overlay. And that's what gives a level of sophistication and security on top of it. And now the overlay with the overlay blockchain on top of that, those create kind of a meshing and a coupling together, which provides you an ability to say, okay, well, this cryptographic EID that's persistent with this cryptographic ledger shows that this is an account of somebody. And now it even makes it harder to forge an account, because you can set your minimum preference of saying somebody that's had a SIG chain for 3 months and that has, said so many messages or has such and such reputation, because you want to really surround yourself with higher quality people. And I think that's going to make higher quality conversation areas too. I mean, where we see the internet, everybody warns you, or at least from the 90s anyway, me growing up, is, don't meet anybody on the internet because you never know who anybody is. And that's a true statement. But in the same sense, if people were less able to go around and hide behind the shadows of the internet, and you create a little bit more transparency where somebody doesn't necessarily need to know who you are, but you can see at least the reputability and the safety of talking to that person, then I think it's going to make it a much better place where information can be exchanged more freely and open. We know that there's issues with credibility of certain internet sources because anybody can be behind a keyboard and typing something. When we add credibility to that, let alone credibility of the routes and everything, and then preferences that can be associated with that, I think we really build I kind of like Internet 3.0 in a way. I mean, considering that's kind of why we have the Tritium software stack, is it's abstractions within the abstraction or within the layers to kind of complete and add pieces to the internet that are going to make it safer and more open to allow that open connection that should be possible without the dangers and risks associated with, anybody, that showed a gun at anybody, with, a DOS attack or a DDoS or viruses or anything else.
Does anybody have any questions? You could ask them now or type them in the chat window.
I have one. Going back to your last statement about the mapping and how the public keys are public in that mapping system, how will that work when with Tritium the public keys are never repeated and never showed until they're hashed and in use?
Yeah, good question. So these public keys here are key pairs that are used at the network layer. And Tritium will have a set of key pairs that are used per transaction. Now, we can also rekey these key pairs anytime we like down at the network layer independently from the Nexus layer. We've had a lot of discussions about should EIDs, crypto EIDs, be persistent versus not. And they can be persistent because we have a blockchain that allows the ownership to be validated, and actually we could even transfer ownership with the register and operation layer APIs. So to answer your question, Anastasia, that these public keys here are ones that are put into the mapping system. The way I have the demo set up is that each one that is generating their own key pairs are registering these as well. And we're going to take some ideas from Tritium by saying, rather than having a third party register these public keys so the map server can verify, that each one will register themselves. But since we'll encrypt the map register messages, these public keys won't even show, that you can't even see them in plain text as they're moving across the network. So it's a little bit, it's actually more secure than the blockchain. However, the blockchain doesn't have to worry about sending public keys when it needs to do a transaction, because now since it's running over LISP crypto, even those public keys are going to be encrypted as well. So there's lots of layers of security here, both from an authentication point of view and a confidentiality point of view.
And to add a point to, when you create your Genesis transaction, you create your very first public key. This is a different type of curve. So in the same parameters of your username, password, PIN, you're going to be able to generate your very first LISP public key or private key and public key pair. And then you're going to register that public key in the LISP mapping system. And we've discussed too, having a similar type of chaining of your public keys where you can say, okay, well, if I own the public key and I have the private key that makes a signature for my initial public key, that is my crypto EID, which essentially your crypto ID is a hashed public key, I can then therefore make another signature with a new public key to register a new public key, and do the similar type of thing like with Tritium signature chains, where you can actually change your keys on demand with LISP, but you'll still have that persistent EID, which is kind of like your Genesis ID for Tritium. So that's another feature that we're working on too, to help create that higher layers of key persistence while still allowing the keys to be changed.
So basically that means that there's kind of like two public keys, one for transactions on the blockchain, and then one specific to the EIDs that can also be obfuscated on the mapping level, right?
And the public key that's generated, both of them are generated from similar key phrases, but we just add a little different prefix for the list specific ones. So it's kind of like two signature chains. You have your main transaction signature chains, and then you'll have your list EID signature chains, which will kind of operate in a lower level. And we're still working out exactly how much we're going to want to rekey and everything like that, but that's an option that we're going to give people. So yes, if you own that original public key that formed your EID, then you'll be able to register new public keys along in your chain.
Okay, cool. Yeah, thank you, guys.
One of the open questions is how ephemeral will these keys be? And they're extremely ephemeral for blockchain because it's more secure. And then the question is do they need to be ephemeral to network layer? And if they have the same frequency of changing at the application layer, can we combine them and use the same ones? So we're not sure if making it common versus decouple is the right way. So we're going to learn about that as we continue to do testing.
Yep. Yeah, we're probably going to start with just a static key without rekeying the LISP EIDs. And then depending on how ephemeral we want to do it, we can just add that. It doesn't really take too much more machinery or changing to the protocol specs if we have it self-registering. So we'll kind of just play with the parameters as we get it out and see kind of what level we want to do on the list side.
Cool, thank you.
Mm-hmm.
Any other questions from the community?
I don't see any in the chat.
Okay, so we're planning on scheduling, I guess, another meetup, Anastasia, in 2 weeks from today.
Yeah, December 13th will be the next one, and I'll put that up on social media and all the community channels in a week or so to remind everybody.
And what we plan on starting to do is to give you some sneak peeks of what's coming in Tritium. Here's just a brief one-line slide that we'll talk about in 2 weeks on how we're packaging the Nexus daemon and Lispers.net in a container that can then run as a process on any platform. In this particular slide, it's showing it's running on Mac OS, and that the Tritium wallet's running natively as another process, and how they can talk to each other even though these guys aren't running natively. And we did that so we can reduce the permutations of what operating systems we have to support. So these two pieces of software here will run on a Debian-based Linux system. And we're showing how, what we plan on showing is how this client that's running the wallet can talk to these existing Nexus peers, even though they're not running over the overlay. So we can get into some details in a couple weeks on how that works.
Yep. All right. Well, do we have any final questions, comments, suggestions, anything like that?
Well, thanks for attending, everyone, and we will get this recording posted so you have it to look at later if you'd like. And
Definitely.
Thanks again for joining.
Thank you, guys.
Thank you, guys.
Bye-bye.
Thanks, guys. Bye.
Bye-bye.